bottom and you spin it, you're going to get a really cool parabolic mirror. Yeah? Don't go too far into that rabbit hole right now, but I'm just trying to say that that's why it's called the axis of symmetry. And in this case, the axis of symmetry is the y-axis, and everybody knows the y-axis has a really cool name, which is called x equals 0. Good. Now, let's say something that I think you guys are already like kind of screaming out, yelling at the computer screen. It's symmetrical. So every point that I put on the right side, I can put on the left side. Remember how that one got in the club over here? Well, then that means this one gets in the club. This one got in the club, well, then this one gets in the club. And so on. All right. Now, I'll go ahead and connect those as well to make it start to resemble its familiar shape a little bit more. Okay, here we are with a parabola. It's a parabola because of the definition that I explained to you, where any of these distances from the focus to the point to the directrix, make sure that's a right angle right there, right angle, are the same. Now, I'm going to take the shortest one, the shortest, the easiest. Remember that first example I gave you, which I called P. And I'm going to look at that for a second. And I'm going to say that the focus then can be found if I know P. Not only that, though. What else do I need to know? I need to know this point. I wish this thing had more colors. Dang. I'm a color person. I want like the whole rainbow here. I've only got like 5 colors. So the vertex. Okay. If I know the vertex, then I know the focus. Because I know that if the vertex is right here, all I got to do is get on a train and go directly north until I reach the focus. How far? P. Okay? I need to buy a ticket from this station to this station, and it's got to be a P ticket. Okay? So, in order to get from the vertex to the focus, I need to add P. So where is the vertex? The simple answer is there's a formula for a parabola, for every parabola. And actually there's more than one. Yeah, I'm just trying to decide, making like a teacher decision whether I should give you all of them or just one of them. I'm just going to give you one of them, the one that you need to do this, because let's take things one step at a time. This is the formula that you need. I always kind of hated it when my math teachers would just give me formulas. I'd be like, well, where did that come from? Did you just make that up? Or, you know, it's better when you can take a little bit more time and derive it and explain where each term comes from. But I'm already looking down at 15 minutes for this video, and I think the student that asked this question is already regretting it. Okay, that is the formula you need to draw, to determine all the important stuff about a parabola. I told you that you need to know the vertex in order to find the focus. It just happens to be, just randomly, I'm sure I didn't plan this, right? That this is called vertex form for a parabola, okay? So vertex form for a parabola looks like this, and it's got a bunch of letters looks like a algebraic sentence, doesn't it? Okay, here is a variable x, here is a variable y. Okay, those correspond to our axes. We have a value here, a, which is a coefficient that's multiplying a quantity being subtracted, but also crucially, that quantity is being squared. It's this squaring process that's actually creating the parabola itself. And then the plus k is a term that I'll just call the elevator, okay? And that'll lift up your parabola from the vertex being at 0, 0 to, if it was plus 100, that vertex here would go from 0, 0, the origin of the graph, way up to up here, where y is equal to 100. And then we'd have a parabola like that, if k were equal to 100. That's how k functions within the vertex form. Again, though, not the central question from the student. The student's asking me, how do I find the focus? Okay, so my answer was, first you need to know the vertex. That's why I gave you the vertex form. The vertex form is called that because it's really easy to find the vertex if you have the vertex form. This vertex is located at h comma k. Okay, so this vertex is located at h comma k. That's this h and this k. So, quick example, y equals 2x plus 3 squared minus 1. Okay, this is in vertex form. Where's the vertex? At hk. I'll give you 3 seconds to say it out loud, okay? Where's the vertex? Three, -1, okay? Vertex is at 3, because of that 3 and that h. -1 is that k value, okay? So that's where your vertex is. Now that you know how to find a vertex, you know how to find the focus. You thought I would never get to here, but here I am. So now that you know how to find the vertex, which is at hk, you can also find the focus, because what you need to do is look closely at the vertex itself. Okay, actually didn't mean to erase that. The vertex is at hk. Look at the vertex itself. Right? And ask yourself, if I'm traveling on that train from the vertex up here to the focus, do I need to change my direction horizontally at all? Do I need to go to the left or the right in any way? No, I don't. I only need a directly vertical pathway. Okay, so a directly vertical pathway means I'm only going to adjust one of these, either the h or the k. Which one am I going to change in order to get from the vertex to the focus? I'll give you 3 seconds again. Say it out loud. Which one am I going to change to get from the vertex to the focus? I need to change the h or the k. I need to change the k. So the focus. Dun, 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 dun. We're finally there, buddy. The focus is, remember we said we have to change the K. How do I change the K? What's different from this K to that K? P, right? So I just went north, vertical, upwards, P. So I'm H, comma, K plus P. Whew, it's a lot of learning. It's because you asked a question that was a good one. And when good questions get asked, the answers are often somewhat involved. While I'm here and while I've got you, really quick, what's the equation of the directrix? Remember that whole northward trip that we just took from the vertex to the focus? Remember the vertex is at HK? If I want to go from the vertex down here to the y-intercept of the directrix, what do I have to do? Not plus p, but minus p, right? And again, I'm not going to touch my h because I'm not going left or right. H, k, minus p is the location of that point right there. And since that point is the y-intercept, and since this line is horizontal, and I know every line that is horizontal has one thing in common. It's always written as y equals a constant. What's the constant? All I care about now is that, k minus p. So this is y equals k minus p, the directrix. The focus is located at h, comma, k plus p. The vertex is located at hk. This is the definition of a parabola, the equidistant set of points from the focus and the directrix. This is called vertex form, very useful as you can see. And this A becomes a big deal when you start to adjust it. And I sent you guys a Desmos link where you can use the sliders and change these values. So go ahead and do that for yourself. Start messing with that A value and see what happens. You're going to get totally different kinds of parabolas coming your way. That was probably a pretty comprehensive answer to your question. And if there are more details that I can provide, don't hesitate to contact me for further clarification. So, parabola, lovely. Remember, parabolic mirrors are the only ones that will focus the light from the Hubble Space Telescope on that one exact point where those faint stars and galaxies, trillions of light years away, can be collected. Those photons that have traveled for billions of years to reach this mirror finally get there, and they bounce off. Here's a photon, okay, coming from the Andromeda galaxy. And it bounces off of this part of the mirror, and it hits the focus. Here's another photon, and it came from a different nebula cluster, and it bounces off the parabolic mirror and hits the focus. So everything goes to the focus if your parabola is a good one. If you have a spherical aberration, that means that your parabola is not a parabola. It means your parabola is not good. It means you messed up. It means you're an amateur. It means that you made a telescope without a parabola, but with a sphere. And spheres will not focus all of the light in one place. They don't have a focus. There's no such thing. Spheres have a center, the same way circles do, right? So we want parabolas. This is how we get them. This is how we analyze them and talk about them. Thanks, guys. I appreciate your attention. Bit on the long side for the video, but I think it covers the issue.